Before I'm going to tell you something about the project, actually the biggest and most important project that we're currently doing at Alphabet, I would quickly like to introduce Alphabet to you in case you didn't notice we're not Google. Alphabet is a mobility service provider, also known more traditionally as a leasing company. We provide all sorts of vehicles, and not just of BMW Mini, but of all brands and all sorts of mobility solutions to 89 customers in Europe. We hold top 9 positions top 4 positions in 9 European countries, and we currently have over 750,000 vehicles on the road. It is our vision to be the leading provider of outstanding business mobility, and we like to achieve that by designing flexible and innovative solutions that optimize your mobility. Now, why am I telling you this? This is actually the key driver of the project that we're currently doing. Now, at Alphabet, we offer funding solutions for funding a vehicle, like operational lease and financial lease. We offer fleet management services like fuel cards, roadside assistance, insurance, and we offer a bunch of what we call advanced mobility solutions like corporate car sharing or a mobility budget. And mobility budget basically means you don't get a car from your employer, but you get a budget that you can spend on your mobility needs as you see fit. And it's actually these new advanced mobility solutions that are also increasingly more posing a challenge to our current business. Because in our traditional business, it was all about the vehicle and some services that were centered around the vehicle. But what we see now emerging is that it's not actually around the vehicle anymore, it's around the customer with a mobility need. And yes, that customer may still want to have a lease vehicle, but it could well be that you would also like to do corporate car sharing, or that you want to do a rental, and God knows what will happen to our industry when the self-driving vehicle becomes a reality. What we also see is that our current applications are monoliths, and that they're not actually very good with coping from that shift that we're making from vehicle-orientated to customer-orientated. So that is a challenge. And what we decided was, okay, how are we going to deal with this? Because just building another IT solution is not actually going to solve our problem. We have no idea when our industry is going to change, and we're also not quite sure in what direction it's going to change. So what we needed was a platform that is just not another IT solution, but a platform that is actually built for change, that has change incorporated in it. So small services surrounded around the capabilities that we have as a business, something that is easy to use, easy to connect, and easy to change. So that's why actually we've started a project that we call OASIS. And in OASIS, we build those services. And what it does is actually that we're back in the driving seat. That means that where we are now still dependent on monoliths provided by other companies, we say we actually know best what it is that our customers need and what our customers want. And that's also why we want to be in control of the IT solutions that we deliver to our customers. And that's why we're changing to self-build again. Now, I'm not a developer, I'm a business analyst. So I actually know very little about coding. But what I do know is that in our BPM department, we have a couple of missions. One is building a bridge between business and IT, providing operational excellence and continuous improvement. And we find that Camunda in a project is helping us in several ways, and you can find them here on the sheets. I'm not going to mention all of them to you, but I would like to pick out a couple of examples, something that we've experienced in the last couple of times. So one of them is consistency from business to execution. At Alphabet, we always had a number of business models that helped us to go from the overview into the nitty-gritty processes, things like a capability map and a value chain. But what we also discovered was every time that we did a project or when we went to a business unit, that, and if you work in BPM, it will probably not come as a surprise, that reality was something completely different than what was actually in our models. And what we now start finding is, because we, at least for me as a business analyst, because we now have models that we actually execute, that I also know that once I see that model, that is actually how it works, at least within the technical solution that we're providing. I'm under no illusion that around that there will still be a lot of creative Excel sheets and Access thingies. But it is a great advantage because it makes doing change projects so much easier. Another way in which Camunda helps us is, and this is actually something that something from an application that we built. This is about the whole process of the steps that you need to do to order a vehicle for the customer. These are SLA bars. Don't get worried about the amount of red in there. I took this from our development environment. In real life, it's almost completely green. But when we started building this, we were not actually using Camunda yet. So a lot of this was actually steered by code. But what you can see here is that there is actually a lot of dependencies in that whole process of getting a vehicle ordered. And quite a lot of those dependencies were not actually coming from the domain that orders the vehicle, but from all sorts of other processes like registering a vehicle or actually having a valid offer in. And while we were building that, we noticed that the more complexity that we needed to get in there, the number of story points that we needed to invest in actually getting it done was exploding. And I can tell you this was actually, we had done some small things with Camunda, but this actually really triggered it because we simply were not able to manage it anymore. And what we saw is when we started to take out that complexity out of the code again, and were putting that into the models that was and let those steer the SLA bars that you see, that we could reduce the number of story points for a change by at least half. Third one, common language between business and IT. Now, traditionally, also in our company, we had people like me knowing the business who were doing the work up front, doing the business analysis, and then when I've done my work, I went to people like Tiese and my colleagues, development, and say, okay, here's the package of work, now please build it. Not actually knowing what they were coding, and only in the end, you'd have to hope that it turned out like you had designed. It was not working. And what we realized, and that's what we start doing now, is that first of all we needed to get the IT colleagues in at an earlier stage, so already in the design stage, and we use a technique for that called event storming, of which Tiese is going to tell you a little bit more. But the other thing is that I can now actually see what is being built, at least to a certain extent, because I know that that model is actually steering the workflow. And what we've recently also done is introducing business rule tasks, which, first of all, took out even more complexity. So we got rid of some of the spaghetti. And the good thing is, DMN enables me as a business analyst also to see what those rules are. I don't need to go to the code, and that is a huge advantage. And the last advantage that I as a business analyst have is because we work in sprint cycles of 2 weeks, the moment that we go live, immediately data is being gathered. So we get immediate feedback on how the process is performing, and this again helps us to improve the user stories that we do, or to prioritize other user stories. And this is the moment that I'm going to ask Tiese to let you tell something about the architecture that we use to realize all this.
Yes, thank you. I'd like to tell you something about the way our system is structured. And our starting point is always the capabilities that are already defined in terms of business service that Rob already mentioned. We have this outline of the way our business is organized. And we call them services specifically because they offer operations to other parts of the business. And those operations you can think of in terms of business processes. And just to give you some examples, you can think of the way we agree a contract with a customer, the way we operate it during its entire lifetime, any changes you might have to your contract, and the way we manage the assets that are involved in that contract. So all of those vehicles Rob just mentioned, they're all part of processes that handle how we deal with them. And to translate those business services into our technical components, we follow a very simple model where we actually just map them straight one-to-one to each microservice in our landscape. This allows us to have a very close relationship to the way the business is organized, first of all, which is the most important thing, but it also allows us to work on these services independently with multiple teams. And obviously, it also helps us with scaling a service if we need to for technical reasons. If we zoom into the way these services are structured, we make a distinction between the parts of our services that offer behavior, commands, and those that offer information in terms of view models. And this allows us to have a relatively small part of the service that's actually focused on the behavior of the service, and an even larger part of the service that offers different ways of looking at that information. And we'll see a case later on where that comes in very handy, related to processes. Some of the logic that we implement, though, in these services is quite complex due to the nature of the business. And the way we capture this is by employing domain-driven design in addition to the other things I just mentioned. And you can think of this as the domain becoming the focal point of all of the analysis work we do and all of the development. So we're really focused on getting all of the details and the complexity that's in that domain in there. The view models and the commands simply utilize that domain to execute their functionality. And because we have an ambition to move towards more straight-through processing, we also know that we will have to implement a lot more of our business logic in the system itself. So it's no longer in the heads of the people actually executing the work, but the system will be performing this behavior. So we need a way to scale the business logic more easily, and domain-driven design is a proven way of doing that very well. What's also very important with domain-driven design is experimenting with the domain, finding out new models that work even better. And by employing this hexagonal approach, which you may also know as ports and adapters, we're able to abstract from some of the more technical capabilities of the service, like storing information or going out to other systems, while we're figuring out what the domain, first of all, should look like, and then later on we implement these additional parts of the service. Just to give you an idea of our technology stack, we do everything with Java EE8. Those applications connect to a Postgres database. We have apps that we write in Angular. We deploy that on Payara Micro, package it in Docker, deploy it to OpenShift, which is a Kubernetes implementation, and we also have Kafka in our stack, which we'll see later where that comes in handy. Still though, with all of this structure and these ideas of how we'd like to set up our components, we have the issue that our actual business processes traverse all of these different services. And that makes sense because a business process, end-to-end, needs to utilize different parts of the business to get things done. And we tackle this by following the same model, really, where we allocate a specific hexagon in our architecture for process. And Rob already mentioned this is one of the advantages we gain by extracting the process logic from the code itself, so untangling the spaghetti and putting the process capability in the service directly, with the domain it belongs to as well. Technically speaking, that means that we integrate a Camunda engine embedded in each of these services, at least in each of them that needs to execute processes or part of them. And of course, we have some, let's say, bootstrapping code, shared stuff that we use to do it the same way everywhere that you can override if you need to. And that allows us to automate all of the processes and decisions in that specific service. And it allows us to also look at what's going on in that specific domain by gaining the observability that we get with Camunda. And this also gives us transactional integration with the domain, which on the technical side is very important because you don't want a process that's run further than the actual state of the domain. And this is the advantage of having that embedded engine. Just to give you an idea of how we deploy this, the service itself with that process capability is deployed in a pod, which is just, if you don't know, the deployment unit in Kubernetes. And the same way, we deploy our apps in a separate pod, and we may scale those if we need to. Separately, we deploy an instance of Camunda web app with the cockpit in there, so we can look at the state of the processes running, and it obviously connects to the same database. That's pretty much a standard setup, I guess. Of course, we also have users interacting with this system. And if you think of the service with that process capability in there, we pretty much use the Java API exclusively for this. We don't use the REST API of Camunda. We have our own way of interacting with the apps. And the view models and the commands all use this Java API for Camunda-related functionality. And we do traditional task lists using those commands and queries. But we also do more interesting things where we offer contextual views related to processes. So imagine you're looking at the details of a contract or a car or whatever it may be. And there may be a process running that's related to that specific thing you're looking at. By using the API, we query for relevant tasks or signals that you may be able to send to that process and offer the user the direct access to perform that straight from that context. And in the same way, you just saw the bars. At least I have a lot more green on this one, but it's not actually taken from a real environment. Sorry about that. Those SLA bars give us insight into the progress and performance of these processes, but they're also a way for users to prioritize their work, because from these views you can also drill down immediately into the details of which tasks are in there, and you can start performing them straight from there, and you just get redirected to the correct task to do that. This is a lot of capabilities that we have in there, but then we still need to figure out how we use that in practice. Because we still have this issue that with all of those services having their own process capability, we need to orchestrate the end-to-end process somehow. And the way we do this is, first of all, when we work on a process, we figure out which service is end-to-end responsible for this particular process. And we implement that process there, and it orchestrates its domain, it reacts to events that may occur in that domain. And there may then be parts of the process that it doesn't implement itself, and it can go out to a different service to invoke that operation, which is done synchronously in our case, and it orchestrates because it knows, at this point in my process, I need this to be done, I just don't implement it myself. Of course, in many cases, we're also interested in the results of those executions. And in that case, we choreograph the results back over Kafka to the orchestrating service. And you can see here that we make an explicit distinction between, let's say, upstream and downstream processes. One is orchestrating and the other is part of a choreography. And I know that Bernd also just mentioned, it depends. It's really dependent on the business case, which process is in the lead, and that determines how this setup gets done, but we want that explicit management. We don't want a peer-to-peer event chain, as it's sometimes called, this spontaneous process. We want to somehow control it, and that's why we combine both of these approaches. Still, we need to figure out how a process actually fits together in practice, and this is where this life cycle model comes in, because we start with an idea of part of our business, how that should operate, and one of the very first things we then do is we start off with an event storming session. And the way this is done, and I assume many of you may have heard of this workshop technique, but just to give you an idea, we get everybody who's involved in this process in the same room. That's the most important part. So subject matter experts, caseworkers, business analysts like Rob, developers like me, testers even, product owners, whoever may be involved, and they discuss the structure of the process by identifying all of the important events that happen. And not only does this give us a basic structure, it typically also points to the exact interaction points between these different business services that we have, because you identify them by just discussing them and figuring out, hey, this is actually done in a different part of the business. That might be relevant to know. And there's a technique you can use with event storming where you detail it even further than just the events, and you figure out which commands, which view models are involved in executing those commands, and you can see the parallel there to the rest of the components in our architecture. More importantly, you figure out what the policies are that are involved in a process. And a policy you can think of as the way you define how an event that occurred is transformed into a command that needs to be performed. And we see all of these policies, the chain of all of these policies we execute, exactly as the business process we're trying to perform. And that results in the BPMN model that we use. And one of the main advantages we gain from doing it this way is that everybody who was in the same room working on that event storming immediately understands the BPMN model, because it's the same thing. We worked on that together, and we don't have this handover anymore where there was a business analysis first, and then it was handed over to the technical people, so to speak, to start implementing that without the understanding of why the model is actually that way. Then, of course, we execute it with Camunda, and Rob already mentioned, from that execution we gain a lot of insights into the performance of that process and how we would like to improve it. And one of the tools we're looking at for the future to do this even more is, of course, optimize. But that event storming technique and having that mapping between the functional model, the way the functional people look at it, and the technical people helps us to bridge that other gap in the cycle. If we look at the more technical way this is structured in the application itself, we typically see these kinds of patterns. This is just an example, but let's say a user executes a command, and in domain-driven design terms, a command is always executed on an aggregate. And an aggregate you can just think of as the logical collection of information, and more importantly, the behavior that goes with that information of a certain domain concept. Once that command is executed, it may result in an event, and that event is exactly caught by the policy, which lives in the process hexagon, so that's in the Camunda process, and it will then decide, for instance, to issue a different command on the same or a different aggregate, whatever is the case. And that event, and all of these events, are those from the event storming. I hope that's clear. That event might be used to update a view model, synchronously, asynchronously, depending on the use case. Or the aggregate may decide that it needs to go out to an external system to fulfill some functionality, and it can issue a command on an external system, and events can come flowing back in that the domain can then respond to. So these are the kinds of patterns and the way this works within the service itself, how all of these things work together. Now, that's all more or less traditional control flow, orchestration, choreography. There are a couple of different ways in which we use Camunda as well. And one of those has to do with those aggregates, because one of the ideas behind an aggregate is that you always retrieve or store it as a whole. You never retrieve a part of it or reference a part of it. And the way we do this technically is we store the JSON representation of that aggregate straight up in the database. But I already mentioned that exploring the domain, experimenting with it, is one of the core tenets of domain-driven design. So sometimes we find out that the domain actually needs to evolve, needs to change. And the structure will change of the representation in some cases. And the way we intend to use Camunda in the near future for this is to have batches running with lower priority, thank you, that upgrade all of these instances that we have, because there maybe potentially millions, and we don't want to bring the system down just to upgrade all of our data that's in there. So that's the way we intend to use it. Similarly, we have some systems we need to integrate with that don't really have the same view on the business process as we do. So we have a single activity, and that's all we want to perform on the business process level. But it requires us to do multiple asynchronous things, retry, do exception handling, and in those cases we extract that into a technical flow, which we still execute with Camunda. And so we have all of the visibility in there, and we can go in and we can intervene if we need to, because things do go wrong in a distributed system. But at the business process level, we still have that view of what the single activity is that we wanted to perform there. So it's a very useful way of using the same framework for a different problem. When we started the project, we actually didn't have a decision yet on whether we would have a multi-tenant or a single-tenant system. And obviously, we knew we would have to operate in different markets. At the moment, we're still focused on just one. But we have a tenant-unaware system. And there's no API in Camunda to switch a tenant-unaware process instance to a tenant. And we imagine that there's a very good reason for not having that possibility, because that could result in all kinds of trouble. So we needed a way to move to a multi-tenant system without having to do it all at once, because that would be quite risky and involve quite a lot of changes straight away. And together with consulting from Camunda, we came up with this approach where we started to at least start new instances tenant-aware. That's the first step. And then we start changing the functionality to actually be aware of the tenant and act accordingly. For instance, go to the right data store that's only for that specific tenant. Later on, we will switch our task handling apps to only deal with a single tenant, because users always act in the context of one tenant. And if there is anything left at the point where we need to introduce our second tenant, we will migrate at the database level. And we're hoping that we, just by being proactive, we will prevent that from being necessary, although we have it lined up just in case. We also do specific things with tasks where we want to do more straight-through processing. But we still have a lot of manual work at the moment. We're still in the process of upgrading a lot of those tasks towards more automation. But we want to have this insight into our process performance, and we want to be able to improve them. And the first challenge we face is actually defining the work that's being done as tasks. Up till now, a lot of the systems people have used have been very much focused on data entry. So they're used to that way of working. And just as DDD is all about getting behavior, we're also focused on extracting the actual tasks people are working on, so we can get that consistency in the operation by executing everything through a process. So we don't do changes in the system that don't run through a process, because in our view, everything is a process, how small it may be. And this is where these task view models come in handy. I mentioned before that we can have separate models, view models in each service, and specifically for tasks, we create unique models for that task. We can easily change them, we can throw them away if we no longer need them, or if we automate a step away. And so that's where we use this in practice. We also have more specific things where these view models and commands may not be executed just by anybody who's authorized, but in some... Oh, I think we lost the microphone there. Thank you. Only the assignee of a task is allowed to even access the information, because it's personally identifiable and stuff like that. The way we solve this is by, when you claim a task, we issue a separate JSON Web Token that's the only one that can actually access that information. We documented a lot of the things that I was just talking about in patterns, because we found it very useful to have an internal resource that describes the way we use Camunda. We train people how to use BPMN, but that doesn't still tell you how we use it in practice and what kind of patterns we came across. So that's a resource we have there to discuss and refer to. We did run into a couple of things, of course. We hit a snag with a local variable scope on return values of service tasks in multi-instances, and this is one of those cases where we found an answer on the forum. Yeah, I know it's quite a mouthful. If you're interested in the details, I can tell you later. It's something that's kind of counterintuitive, but we figured it out on the forum because somebody had run into this before, and it was easily solved after that. We also have an issue with database migrations because we have all of these services running around on all these different environments, and we need a way, when we upgrade Camunda, to upgrade the database. And there's no out-of-the-box way for doing that, so we wrote our own, based on Kubernetes init containers, to upgrade the database schema before we actually deploy a new version, which has a different engine. The same goes actually for AssertJ. We had a conflict with our version of AssertJ with the test assertions. So we couldn't use the community extension, but since it's now part of, not literally part of the core, but it's more integrated into the product stack, we can now upgrade our version to the newer version because we can do the database migration. We can also start writing even better tests for our processes. At the time we started, there was no support for JUnit 5. We just took a peek at the JUnit 4 implementation and rewrote a JUnit 5 extension to be able to use that as we do elsewhere in our system. Of course, it's been mentioned a couple of times by now, we also have this issue of end-to-end visibility. So we're very happy to see that Optimize will have this capability in the future because we have cockpits deployed individually for each service, which only gives us that view. Yes, we could write something ourselves, but it's even better if somebody else can do that for us with more knowledge of how to then also analyze what's going on. We also noticed that there was still some BPMN support lacking in the framework, errors and escalations on tasks, and just this week, somebody at Camunda actually completed work based on our feature request. So we're looking forward to that in a future release as well. On the modeling side, we noticed that orchestration modeling is excellent in Modeler. Choreography is not there at the moment. Yes, you can model them in BPMN processes, but in our case, it would be very useful to also be able to model BPMN choreographies because there's a native way of doing that, exactly for these touch points between all of these services to get those. I know it's a loaded term, conversations. It means something else, but that's the conversation that's going on in the context of that business process. We would like to be able to have a standard way of modeling that. On the community side, I mentioned the forum. We gained a lot of insight from information that was there. We also provided some of our own feedback. And we took a lot of learnings also from extension and plugins that are out there in the community. Some of them we used straight out. Other ones weren't applicable to us, but there were good ideas in there that we could use and use in a different way for ourselves. We also used the support option a couple of times. And that was not only very helpful, but it was also a lot of fun working with people from Camunda. That's all we brought for today. Thank you very much.
Thank you.